This is what happens if humans start flying close to the sun. What if we just pointed a ship at the sun and went for it? No black holes, no distant galaxies, our very own star. It seems simple, right? A bright ball of fire in the sky. But let me tell you, the journey to touch the sun is one of the most metal, terrifying, and mind-bending trips physics can imagine. What would you see as you get closer? What would kill you first? And is there any scenario where you could survive? Hey everyone, welcome back. Today we're embarking on a one-way thought experiment, a human voyage to kiss the sun. Buckle up, because by the end of this, you'll understand why the sun is the ultimate boss level of our solar system. Segment 1. The launch pad, leaving Earth's comfort zone. So, we blast off from Earth. Our first realization? We're leaving the ultimate life support system. We're in the Goldilocks zone. Not too hot, not too cold. But as we turn our ship sunward, we leave that comfort behind. Almost immediately, we're dealing with the raw vacuum of space. No sound, just silence, and the growing dot of our target. But here's a cool fact. We've actually set something on this journey. NASA's Parker Solar Probe. It's the fastest human-made object ever, and it's diving through the sun's atmosphere. Everything we'll talk about is based on real data from missions like Parker. Our imaginary ship is just a less durable version with a human inside. Sorry, crew. Segment 2. Entering the solar atmosphere, the corona's fiery mystery. Our first major milestone, the corona. You've seen it during a total solar eclipse, that beautiful, wispy halo around the darkened moon. This is the sun's outer atmosphere, and it holds the first of many solar paradoxes. Paradox number 1. The scorching corona. The surface of the sun is about 10,000 Fahrenheit, 5,500 degrees C. Hot, right? But as we move away from the surface into the corona, the temperature spikes to millions of degrees. Millions. Why? It's one of solar physics' biggest mysteries, likely involving the sun's crazy magnetic fields twisting and snapping, accelerating particles to insane speeds. But, and this is crucial, temperature here doesn't mean heat like we feel. It's a measure of particle speed. The corona is so thin, it's almost a perfect vacuum. So while the particles are insanely energetic, there aren't many of them to transfer that heat to our ship. Yet. Our ship's hull might not instantly melt here, but it would be bombarded by the solar wind, a constant supersonic stream of charged particles. Our electronics would be screaming. Segment 3. Descent into hell, surface and below. Now we push further. We pass through the corona and approach the visible surface, the photosphere. This is the surface we see from Earth. It's not solid. It's a roiling ocean of plasma, bubbling like boiling oatmeal in Ultra HD. Here, the density increases. Heat transfer becomes a real, immediate problem. Our ship's material science would need to be magic. We're talking temperatures solidifying around that 10,000 Fahrenheit mark. Any viewport would be blindingly bright, brighter than millions of welder's arcs. Without insane filters, you'd be instantly, permanently blinded. And then, solar weather. We might fly past a solar prominence, a loop of plasma the size of planets, dancing in slow motion. Or worse, get hit by a solar flare. A sudden, violent burst of radiation. That's an instant mission killer. A wave of X-rays and gamma rays would fry every system and give you a lethal dose of radiation in seconds. But let's say our magic ship survives. We go through the photosphere. Now we're inside the sun. No more flying near. We're flying into it. The plasma gets incredibly dense, like liquid. The pressure is unimaginable. Millions of times Earth's atmospheric pressure. Our ship isn't flying anymore. It's being crushed, melted, and vaporized all at once. the physics changes. Light can't travel in straight lines here. Photons bounce around in a random walk, taking thousands of years to get from the core to the surface. You'd be surrounded by a glowing, opaque soup of plasma. Navigation? Impossible. You're a speck in a star furnace. Segment 4. The final frontier, the core and the grand takeaway. If our ship could be made of pure force fields and miracles, and we descended for hundreds of thousands of kilometers, we'd reach the core. This is the engine room. Here, gravity's crush is so intense that hydrogen atoms are fused into helium. This is nuclear fusion. Every second, millions of tons of mass are converted into pure energy via E equals mc squared. This is what powers every star in the sky. You are now at the heart of a self-sustaining nuclear explosion, 330,000 times more massive than Earth. The temperature? 27 million degrees Fahrenheit, 15 million degrees C. The concept of ship or human has no meaning here. Our atoms would be stripped apart and incorporated into the solar plasma, maybe eventually being fused into new elements or shot out in the solar wind millions of years later. So, what's the takeaway? This thought experiment isn't just about melting. It's about appreciating the sheer scale and ferocity of the star that gives us life. It's a constant, titanic balance between gravity trying to crush it and fusion trying to blow it apart. That balance gives us light, heat, and the energy for almost all life on Earth. We can't touch the sun, but by daring to study it, by sending probes like Parker into that inferno, we learn about the fundamental forces that shape our universe and our very existence. So, could a human fly close to the sun? Absolutely not in any way we can currently imagine. It's a journey of paradoxes, of intense heat in near vacuums, of beautiful coronas, and planet-swallowing flares. It's the most hostile environment imaginable, and yet it's the reason we're here. That's the beauty of science. We can take these impossible journeys in our minds, guided by physics, and come back with a greater sense of awe. If you enjoyed this deep dive into our star, smash that like button. It helps this channel grow. What impossible journey should we take next? A dive into Jupiter? A ride on a comet? Let me know in the comments below. And if you haven't already, hit subscribe and ring the notification bell so you don't miss our next exploration. Until next time, keep looking up. Thanks for watching.